Okay, so we made a study of social motor intention in human-robot interaction, and the aim of this is to develop a new design of human social robots interaction grounded in low-level motor processing and drawing on intuitive interaction where people naturally can read and perceive intention in action. And the idea is to make cooperation emerge directly from kinematics. The background of this study is research about motor intention in human-human interaction, and there's very strong evidence of these findings that we use and have the basis for our study. So there are three key notions to this, and there's a social context, which is defined by an observer nearby, near in the vicinity of the agent that is attending in the direction of the agent and is capable of actually intervening into the activity. And the presence of this observer, the presence of a social context, will prompt a social motor intention in the agent. So the second key notion is the social intention, and that's an intention to influence other agents' behavior, and it overrides individual intention and automatically will cause an interactive response in the observer, in the other agent. And so the third key notion is social motor priming, and this is what happens when the motor system plans for a complementary action after the observation of a social intention in somebody else's behavior. So it's a totally automatic and implicit mechanism. So the idea is that social intention is encoded in the movement kinematics of the motor action. So it's visible directly, it's directly perceivable from behavior, and is characterized by exaggerated spatial temporal properties of the movement, like higher curved trajectory of the arm reaching forward, lower velocity, longer movement duration, and higher maximum height of wrist and hand. And this social intention then will induce a sharing of information between the agent and the observer. So the kinematics, which is exaggerated, then it will facilitate for the observer to intervene in the agent's activity, and it facilitates responding, and so enables joint action, and which means that social intention in practice functions as an invitation to cooperate, but an implicit invitation. So to summarize, the basic idea of this study is that there is a social context, it will prompt social intention in the agent, and it has a characteristic movement kinematics that is directly perceivable. Social intention in the agent will cause a social intention in the observer, and this will prompt reciprocal behavior between the two agents. And then we'll have the emergence of an interactive loop that automatically will generate human-robot cooperation. And in the study, we tested the hypothesis that the observation of social intention encoded in the movement kinematics of a humanoid robot will modulate the movement kinematics of the observer's motor action and trigger complementary and social interactive behavior. So the study was an interactive behavioral study, and we also had a questionnaire to investigate the user's experience of interaction. So interactive study means that a human and robot interact face to face. So it's a kind of second person approach. They are interacting as an I and a you, so to speak. We had 44 subjects, and we're all students who recruited on campus, and we used a between subjects design with each participant taking part in one single trial. And finally, we used EPI, which is our own humanoid robot, which has been developed here at Lund. The task, so EPI is standing by a table, and the human participant enters and sits down on the other side of the table. And there are two blocks lying on the table next to EPI and the human participant. And the instructions is to first watch the robot place a block on the surface or in the table between the participant and EPI, and then wait till EPI has finished its task, and then to place another block on top of the robot's block. So there are three conditions. The robot will perform the action with one of three kinematic profiles, and there will be one profile per trial, as I already said. So the three conditions, they correspond to the three kinematic profiles. In condition A, there is the individual movement. So there's a reaching movement which is efficient and signals an individual intention. The hand and the arm takes the closest comfortable route to the goal, and the trajectory is straight. Condition B, we have the controlled condition, and I won't say much about that because we don't have much time. And then there is a condition C, which is a social movement where the reaching is accelerated and is signaling a social intention. And I already described that with movement has spatial and temporal properties that are amplified with a curved trajectory and larger motion. Importantly, what is important about this setup of the experiment is that the task is actually consists of two independent actions, and also we avoided an influence of eye gaze on the behavior. And then the behavior analysis, we looked at social movement, which was then operationalized in terms of this kinematic profile with social intention. And we looked at social interactive behavior, which was operationalized in terms of looks towards the robot's eyes, attempts to make eye contact and so on. And actually this is the kind of behavior that is used to measure turn taking, and it predicts engagement. Now, for the results of the behavioral study first, so when it comes to social movement in the human participant, in condition A, after having observed EPI perform an efficient movement, there were 30% of the participants performed a social movement. But in condition C, having observed EPI perform a social movement, 90% performed a social movement in response to EPIs. So that was a very good result. We can see that the kinematic profile prompts this social behavior, the social movement. So the participant reciprocated EPI. And also social interactive behavior in the human participant in condition A, we saw it in about 25 to 30% of participants, while in condition C, where EPI performed this social movement with the social signaling, the social intention to cooperate, about 75% of the participant looked to the robot's eyes before, during, and after the interaction, and also attempted to re-engage all these behaviors typical for turn taking. Then we have the results from the questionnaire. And an important question was, do you think robot was cooperative? Condition A, less than 25% thought so. In condition C, about 60% thought so. And then, did the robot focus on you? Both conditions, the participants, about 30% said yes. Did the robot focus on the block? Was very much higher percentage that answered in the positive, which means that to be cooperative is conceived of as something having to do with focusing on the block and not like a social engagement thing. This is what these two questions indicate. And then finally, the predictability and legibility of the robot movements was considered high, which of course is important for the answers. So conclusions about this novel approach to human-robot interaction. Well, we did demonstrate social motor priming, and the users did engage spontaneously with the robot. And this is, or constitutes actually, what, in our opinion, a fast track to cooperation with spontaneous sharing of information, shorter reaction times, efficient behavior. We have reciprocity and complementary actions even, with the human achieving the actions of and completing the actions of the robot. Why did we succeed? Well, we think there are three reasons for this. First, we have a better technology, of course, using EPI. And then we also, the study, we used an interactive paradigm, the second person approach, which makes other and more social information available to the participants. And this means that the ecological validity also was increased. Thank you.